a little bit.
That's scary though.
Yeah, I know. Pretty scary. So we're actually going to wrap up section 3.4, but we're also going to do section 3.5. See if we can't get a hold of it on here. So this is like 3.4/3.5, like awesomeness. Okay. So let's wrap up 3.4 first. We're still solving inequalities. Really, all we need to remember, for the most part, that's different is if we divide by what? Or multiply by, finish the rule.
Negative, you put the thingy.
By a negative, flip the symbol, right? And we also want the variable on the left. All right, so let's say I have 17 minus 4x minus 2 is greater than or equal to 2 times x plus 3. What should we do first? And Reagan, if you could shut the door.
Distribute.
Yes. So I'm going to distribute the 2 and get 2x plus 6. And now I need to distribute this negative. Make sure it applies to everything. Ideas. What should we do next?
Do 17 plus 2.
Yes. So I'll get negative 4x. So just copy that down, and 17 plus 2 is 19. Now what?
Subtracting it.
Yeah. Since I want the variable on the left anyway, I might as well get it there right away. So negative 6x plus 19 is greater than or equal to 6.
Yeah.
Notice that even though I subtracted and got a negative, I didn't flip this. I only flip my symbol if I divide or multiply by a negative. And go ahead, Ryan.
And now subtract the 19.
Subtract the 19. And now what?
Divide by 6. Negative 6.
Well, negative 6, not the x. So I divided by a negative. I flip my symbol. And a negative divided negative is positive, so I get 13/6. And that's fine. That's just over 2. Okay. We'll do one with some fractions just because I know how much you like them. And then we'll jump into section 3.5. Because you guys are just that phenomenal. Okay. You got that? You good? You write all that down over there?
No.
Write it in here.
Okay, next one. That's an H right there.
So what?
8.
I thought he said eat.
Now, what do you think we need to do?
You have to get the common
Least common
denominator
denominator.
is 24.
Yes, the least common denominator is 24. So I multiply both sides by what?
4.
I distribute, and 2 cancels, so I have,
X.
and here, what cancels?
3.
So I get 8. So it's minus is greater than or equal to. We distribute here.
24.
Okay, so the 24 cancels with 4, and I get,
8.
careful,
I'm just getting sick.
and then 6 times 3 is, see how we do that? And then next one, 24 divided 6 is,
4.
so 4 times 5 is, You see how we do that?
You're about to go to 4.
Okay. That's 12 right there, not a 72. Now what do we do?
Combine the x's.
Can't. They're on opposite sides.
I mean, I didn't mean combine, I meant like subtract it.
So let's subtract the 20. That way we have our x on the left, so we'll get negative 8x. Now what?
Plus, I meant subtract the, I meant add the 3.
Add the 3. Can you even talk?
Nope.
Alright, and then we,
Divide by negative
yes. So x is,
8. 21 over negative 8.
well,
Oh,
we'll
you
move
can-
that negative up,
Yeah.
but what's our
Yes.
symbol?
Oh, you use
It's less than.
Yeah, because we need to flip it when we divide by a negative. Now, if for some reason we had something like negative x plus 4 is greater than 2. Let's do that. What should we do?
Subtract the 4.
Okay, we get negative 2. Now what?
Divide the negatives.
So I get x.
As less than 2.
Okay, good. Good. All right, so that pretty much wraps up that section. The solving is pretty much the same. So we are going to go on to compound inequalities. Compound inequalities. So we have two of them. We have our and, which has this symbol, and it's called a conjunction. And we also leave some space here. We also have or, which has this symbol, and that's a disjunction. All right, so conjunctions, basically you could think of as a sandwich. And, well, the disjunction is just the opposite of that. Not the sandwich. It's a, I don't know, what's not a sandwich?
It's a hamburger.
That's a sandwich. Hamburger.
Macaroni and
it
cheese.
That's a kind of sandwich.
got bread.
Okay.
Salad.
This is an inverted sandwich, which basically you throw everything around. Okay, but we'll see what that is in a moment. So let's say I had 3 is less than x is less than equal to 5. Notice I have two inequalities here, and the x is sandwiched in between them. So if I were to graph that, I'd have my 3, I'd have my 5. See, closed circle here. So closed circle at 5. Open circle at 3, and then x is in between those, so I connect them like that.
Yeah.
I have so many questions.
So do they all? I can't talk. Do they always go to the middle? Like every time?
Not always, but mostly. Let's say I had negative 4 is less than equal to x is less than negative 1. So if I were to graph that, negative 4, see left, negative 3, negative 2, negative 1. Open circle at the 1. Closed circle at the negative 4. And a sandwich in between them.
So where
I don't
does
like
the
this kind of sandwich. I like the other kind of sandwich.
Yeah, I know.
I'm getting a sandwich.
Yes.
where does the and and or come in?
I'm about to show you that. Now this is actually, this one does have an and. Because we read this, 3 is less than x, and x is less than equal to 5. That's how we actually read that. Or for short, 3 is less than x is less than equal to 5. And this one we would read, negative 4 is less than equal to x, and x is less than negative 1. So we can split that, and I'll actually erase this little piece right here, and we'll get back to that. So this, we could think of as 3 is less than x, and x is less than or equal to 5. See, these mean the same thing. It's just more convenient to write it like this in a sandwich form. And this one we could think of as -4 is less than or equal to x, and x is less than -1. Now, someone had asked earlier, do we always end up with a sandwich like that? Usually we do, but not always. So I'm going to do with you the examples that it does not end up like that. And these can be kind of confusing, but if you graph them, it won't be that bad. So we need to think of and as meaning both. As in, I want overlap. And if I don't get overlap, then there's a problem. So if I have, say, x is greater than 1, and x is greater than 3. Well, let's graph that. So let's get our number line. And here's our 1. Trust me, if you graph these, they will make sense. If you don't, then you'll be bonobo and you won't know what's going on.
Too late.
So we have an open circle at 1. In which way do we go?
Right.
To the right? Okay, and this one, we have an open circle at 3. In which way do we go?
To the right.
To the right. Now notice in this case, both of them go to the right. Now where do I have overlap? Well, I have overlap starting right about here. See, I'm coloring it in. So what's my answer? Well, I have overlap starting at what number?
3.
So x is greater than 3 is actually the simplest answer. That's what that is. So even though I had the conjunction and, it's simplified down to just one thing. So that's the exception to the sandwich. There's another exception.
Wait, what? I'm sorry.
Okay, so I graphed both of these, and I looked for where there's overlap. There's overlap starting at 3.
Okay.
So x is greater than 3. All right, let's say I had x is less than or equal to -4, and x is less than 2. So if I graph that, let's see what happens. So we have -4, -3, -2, -1, 0, 1, 2. Might as well get a -5 in there. All right, so this one, how do I graph that?
Color in the circle.
And which way do I go?
The left.
Okay, and this one,
You go to the left.
open circle at 2, and go to the left. And where do I have overlap? Well, starting at -4. So what will my answer be? X is less than or equal to -4.
How do you know what side of it?
Well, see, this is going to the left, right? So,
But
less
like,
than.
with the last one too, how did you know?
See, these are going to the right.
How do
See?
you, how do you know to put the less than equal to?
If it's colored in. This one's not colored in.
Okay, so if one of them is colored in, you do less.
Well, if the one starting at the overlap is colored in. Whether this one's colored in or not doesn't matter. If I colored that one in and this one's not colored in, then I don't have the equal to. All right, one more exception. I mean, there's lots of different styles here. So we have 2, 1, 3, 4. How do I graph that? Well, an open circle at 2 and go which way?
The right. Nope, the left.
Left. And this one, open circle at 3 and go which way?
Right.
Now for and, I'm looking for both. There's no overlap.
No solution.
Yep. No solution. Or you could write it as an empty set. So you do this. That means no solution. This also means no solution. It's kind of more null.
Can you just let me know?
Any of these three, it's fine.
Just do no solution.
It's fine. Okay. Any questions on conjunction? Now we can solve a conjunction. This is really what I want us to be able to do. So this is going to be like the most important. Okay? Notice I have a sandwich, so that's a conjunction. So now I can build my wall, but now I have 3 spaces. How do I solve for x? I subtract 3. And I get negative 1 is less than equal to x is less than, not equal to, but less than 6. You see how I did that? I just solved in 3 spots. I tell you, my geometry students need helmets so bad. What do you think we do on this one to solve it?
Multiply.
Multiply by what?
2.
So on the left I'll get
10.
is less than,
Means x plus 2.
is less than,
14.
and then what do I do?
Subtract 2.
So I get
8.
is less than,
X.
is less than
10. 11 and 12.
12. Huh. And of course the rules with negatives apply also.
Do we still have to flip it if it's a negative?
Yes. In fact, we're going to do one now. Let's see. Say I have 4 is less than, hold on. All right. How do we solve that? I can, but if I can undo this addition or subtraction, I want to undo that first. So I'll subtract 3 first. So I'll get 1 is less than negative x over 2 is less than equal to 3. Now, less than equal to 7. Now, if you multiply it by 2 and you made sure you multiply that 3 also by 2, then that's okay. You would get a 6 there. Now what do we do?
Multiply with 2.
So we get 2 is less than negative x is less than equal to.
14.
Now what do I have to do?
You have
Divide by the negative.
So I get negative 2 is what happens to this?
Flips.
So now it's negative 2 is greater than x is greater than equal to
14.
negative 14. Okay, because I multiplied by a negative. Now, this is reversed. Well, what do I mean reversed? I mean, it's technically not wrong. I could say negative 2 is greater than x is greater than equal to negative 14. That's true. But for easy graphing, I want the smaller number on the left. So whenever I end up with greater thans on these, I want to flip the entire thing around. With x in the middle, and then this symbol is going to end up over here, and this symbol is going to end up over here, but it's going to be a less than. That way it's in the right order. See how I did that? Now, every year, I warn students of the following mistake. And every year, like 75% of you do what I'm about to do, and it is wrong. Do not do this.
You're wrong.
If you get this answer or anything like it, it's wrong. This makes no sense. 7 is greater than x, which is less than 9. That makes no sense.
Right.
Wrong. This is also wrong. 7 is less than x, which is greater than 9. That is also wrong. Those symbols should be pointing the same way. Okay? They should not be opposite each other. Okay? They should be pointing the same way. If we're doing a conjunction with a sandwich, that's the case. They should be pointing the same way. So that's conjunction. I want you to try one on your own. See how you do.
On the whiteboard or on the...
On your whiteboard's fine, if you would like.
What kind of sign?
Perfect one.
That's a lesson or you can do.
Nah, he had...
Oh,
He looked like he...
Oh, these one look like just be.
there you go.
I should draw a picture of Bryson.
Oh my
Thinks he has that cool.
I'm already thinking.
Oh, he has a little tattoo on his arm. I gotta wear his big southern belt.
Adult vocal?
Same difference.
And
I like his pants. They fit very well. It looks like
Okay.
it looks more like a skirt than.
first we subtract the 8. And what do we get on the left?
-1.
Is less than or equal to negative 3x is less than 3. I need to subtract 8 from 3 things because I have 3 symbols. Now what do I do?
Divide by 3. -3. I mean.
So I divide everything by negative 3. So at the left I get 1/3. What do I have to do with this?
Flip it.
And then I flip that one as well.
-1.
And then at the very end, last step, this needs to be in order.
Well, you count
Don't
out
be-
that.
It's easy to write. If this number over here is bigger than this number, it's out of order. So just switch them around. You see this symbol? It's pointing towards the -1.
Yo.
See the symbol is pointing towards the x. And that's our final answer. So if you don't get this step, you will lose some points. So you want to make sure you're doing it correct. All right. We need to hit on disjunctions a little bit.
Thank you.
So back in the notes.
Already clicked on that.
Come on, guys. Disjunction or
Start to get tired.
Here's Caitlin's
I feel like I did a lot of those.
You give that to Caitlin.
I want you focused on this, please. All right, let's say I have something like this. 5 plus x is greater than 2, or x is less than -5. So I'm going to solve both. Just like with conjunctions, except with conjunction I could do it, all at once. So on this one on the left, I'm going to subtract 5. You with me?
Where do we draw a wall?
Well, there are 2 different ones. They're separated by that. Okay, so x is greater than -3. And this one is already solved. X is less than. And if I go to graph that, here's -5, here's -3. X is greater than -3, see it goes to the right. And this one, x is less than -5, see it goes to the left. This is our answer. it just happens to graph in opposite ways. I don't say null or no solution here because or, it could be either this or this, one or the other. So that's fine.
So what? So it's not a no solution?
Not if it's an or. It can be either this or either, like or, you gotta think like one or the other. Whereas and or conjunction, you think both. So if I said, if I said to you, think of it like candy. All right. So let's say I have two candies. Let's say I have a Snickers and I have a Twix. And I say to you, you may have a Snickers and a Twix. What are you going to do? You take them both, right? You eat both the Snickers and the Twix, or you hoard them and put them somewhere. You ultimately, listen, ultimately, if I say to you, you can have a Snickers and a Twix, you're taking, gentlemen, you're taking both of the candies, right? Okay, but if I say to you, you can have a Snickers or a Twix, now unless you're a thief, you're going to take either the Snickers or the Twix.
Well, what do you take? Either of them.
Well, then you're a bonobo, and you. I don't know why. I don't know why you exist. Okay, going on. We should be listening.
Make the time for this column changes.
Alright, so I have my OR. I solved this one, so what do I do?
Subtract the 2.
Add the 2.
I meant add the 2.
And then we?
Then you divide the 3, you get 4.
In this one, I add the 2, so what do I get?
8.
And then we?
Divide by 3.
Now that's just past 2 and closer to the negative 3 end. So here's my 4. Here's my negative 3. So this one, open circle at 4 and goes which way?
It goes to the right.
And this one is open or closed circle just before the negative 3. So that's almost negative 3. And which way do I go?
Left.
See how they go in opposite directions? And this is an OR. So I'll put that, and I'll connect these.
Why'd you put the open circle there?
Can't be equal.
No, on the graph.
Because it can't be equal.
I'm at the full circle.
Because this one can be equal.
No.
Less
Why
than.
is it in the spot? Not why is it filled in? Why is it right there?
Why is it where it is?
Okay, well, what's negative 8 divided 3?
It's like
You should calculate what's negative 8 divided 3.
negative 2.7.
So it's between negative 2 and negative 3, which is why it's just to the right of the negative 3. Is because this is this, which is between these two.
Oh, thank you.
All right. So let's say I put 2 of these up here. It's already graphed. And I ask you, all right, write an inequality to describe each of these. So the first one, I see I have a sandwich, which makes me think conjunction or and. So x is between these two things. You with me? So 2 is less than x is less than or equal to 4 because it's between these two. All right, this one I see that they're going in opposite directions. So I'll do this one, x is less than equal to 2, or, because it's a disjunction, x is greater than 4, so that's when they go opposite ways. Do you need me?
Is there student council today?
Yes.
Okay, I saw the email about soccer, so I was wondering if there was student council too.
Yeah. This one, I just have the x is less than 2. And this one, x is greater than or equal to 4. Okay, we did lots of stuff today, so you guys did a good job. Wrap that up in your notes, and I don't know how much time we have, but I want you to turn in your books to page number 157. Just